students, welcome to the chemistry sessions once again. So how you all are doing? I hope you all are doing great and you are maintaining your health as well as your study schedules. So you need to have a proper balance between the two in order to have good marks in your examinations and in order to get selected in NEET or IIT JEE. So basically what we were discussing in the last session was, we had discussed about the anti-fertility drugs, those which are used as the oral contraceptives, and those must be taken with utmost care in order to avoid any kinds of complications within the fertility issues. And what we had started off with a very interesting topic, that is what kind of chemicals are actually added within the food. So we were on to the chemicals in the food. So let us just quickly revise the topic here. What all chemicals are included in the food? So I would like to discuss here two very important, that is the artificial sweeteners which are added as well as the preservatives. So we will be discussing here the artificial sweeteners as well as the preservatives. So now, under the category of chemicals, what kind of chemicals are used? I hope you all have revised the concept. So the chemicals used in the food can be artificial sweeteners, can be flavors, different kind of flavors, different kind of colorings, different kinds of antioxidants are added, preservatives are added in order to actually protect the food or to increase its shell life. And what else do we have? We have various kinds of additions related to the nutrients. That means we add vitamins, we add minerals also. So that means increasing the nutritional value of that food, that particular food. So basically, in order to, why we add chemicals in the food? To increase shell life, that is one thing. And in order to have a good appearance, have a good taste, that means the cosmetic value, that means a good appearance as well as good taste. So that is why the flavors are added. So that is why we add chemicals in the food, in order to maybe increase the nutritional component as well. So nutritional value. Actually, out of all, this is the only point, this is the only thing, this is the only addition which actually benefits us. Now let's move on to the artificial sweeteners. Under this category, what we have started off with was number first, the aspartame. So I hope you all have revised aspartame here. So let me just rub this off first. We are on to the artificial sweeteners. Why there is a need of artificial sweeteners in our food? Some of the sweeteners, that means sucrose or fructose, what do? They have got high calories. They are not beneficial for the diabetic patients. Even they cause tooth decay. So there are so many problems related to the calorie intake of these kind of natural sugars. They also increase our blood sugar levels. So that is not at all beneficial for us. So in order to avoid that, we have developed certain kinds of artificial sweeteners. First, what we have discussed was aspartame. So here is a question for you. Where is actually the aspartame used? In what kind of foods it is used? So I hope you all might be having a slight idea about it, but not exactly. So I would like to tell you here that aspartame is actually used in the cold foods. It is used in cold foods, as well as it is most prominently used in the soft drinks. So it's used in soft drinks, cold drinks you can say. So in cold drinks, in cold foods, it is most commonly used. Very successful sweetener this is. A successful sweetener, or I can say a very popular sweetener. Now, what is actually the drawback of aspartame? So there has been one drawback. Why this is only used in the cold foods and the soft drinks? That means cold kind of foods. Why this is used? Because it actually gets degraded. It gets decomposed when we are talking about cooking, when we are talking about high temperatures and baking. So basically aspartame decomposes at cooking and baking temperatures. So it's not at all stable. So that is why it is only used in the cold drinks. So it is decomposes at cooking and baking temperatures. So that is the only drawback here in the case of aspartame, and also it is 100 times sweeter than sucrose. We are comparing all of these artificial sweeteners one by one with the natural sweetener, that is our sucrose, that is the cane sugar. So it is 100 times sweeter than cane sugar, or I may write that as sucrose. So I hope that is very, very clear to you. How do we make the structure for aspartame? We already have done this. It is actually aspartic acid along with phenylalanine. So it is aspartic acid plus phenylalanine, alanine, methyl ester. So I hope you are able to draw the structure for aspartame on your own. Now let's move on to the another kind of sweetener. What is that? That is saccharin. So I was discussing about the saccharin in the last session. Very, very popular, and it has been used since many years. So it was initially when there was no kind of artificial sugars. So basically this was the substance which was used as at that time as an artificial sweetener. So saccharin, very, very popular. And what is the quality of saccharin? The quality of saccharin is, it is almost 550 times, roughly I am telling you, 550 times sweeter than sucrose. So it is 550 times sweeter than sucrose. So that is how the actual sweetening property of saccharin is. Now about the structure, it is nothing but, we have already done this, orthosulfabenzimide. So it is orthosulfabenzimide. And I had asked you something about this very structure. So the structure is quite simple. That is what is known as the saccharin. And this very structure is insoluble in water. So I may be having a salt of this structure in order to make it soluble within the water, in order to make it a proper sweetening agent. So basically this is insoluble in water. So I had asked you what kind of a salt will that be. So those are nothing but the sodium and the calcium salts. So these are Na or Ca salts, which actually now they are possible, they are actually soluble in the water. So that is the composition of saccharin what we use in the case when we are actually using it as artificial sweetening agent. So I hope you all have got it. Let's just make the salt over here. Very, very simple. You just need to remove this hydrogen and you need to put the metal ion. So that is how you are going to make the salt. So super easy. And what do I have? N minus Ca plus, that is one salt, that is the calcium salt which we can use. And what is the another one? So the another one is, I have got the sodium salt as well. So that is N minus Na plus. So that is what we are going to use. Now these salts are pretty much soluble in water. They are soluble in water. And one thing which I didn't like about saccharin is that this very reagent, this very agent of sweetening is actually what? It is actually non-biodegradable. That means it remains as such in the nature. Whenever you consume a product having this very kind of sweetener, it actually gets excreted out as it is from the urine, in the form of urine. So actually there is no such thing which can degrade this. Although it can get degraded, but not naturally. It is not biodegradable. So that I didn't like about saccharin, and it is also quite harmful sometimes. So basically saccharin is, I would like to mention this over here, the point that I just told. Saccharin is non-biodegradable. That means it gets excreted out as such. It is excreted with urine as such. It does not get deposited in the body, and we can say that is a positive point as well. So it is a positive point maybe that it does not get deposited anywhere within our body. It just gets secreted out. It is just actually serving the purpose of developing a taste within our mouth. So that is the only purpose. What is the purpose of saccharin? Only the development of sweet taste within mouth. In the mouth. And also, what is important about saccharin? What actually can be a possibility? So, in saccharin what we have discussed is, it is 550 times sweeter than the sucrose, very beneficial. And also the structure that we have discussed for it. What else? It is non-biodegradable in nature. And what is a very important point over here is, the diabetic patients can consume this very sweetener. It is not at all harmful for them. So, diabetic patients can consume it. So here this statement implies what? That means it does not have any calories, it does not have any calorific value. So our purpose is very well served over here. That means it will not increase the blood sugar levels, it will not be any type of harmful for the diabetic patients. So that is what the quality of saccharin is. It does not have any calorific value. So I hope that is very well clear to you. Hence this is not at all harmful. Now let's move on to one step ahead. More sweet, what can it be? So the more sweet, or I can say the more sweetening agent will be here is sucralose. Yes, I hope you all have heard about sucralose. If not, we are just going to discuss it. So what is actually sucralose? So here it's the third artificial sweetener, that is sucralose. What is sucralose? It is a trichloro derivative of sucrose. So that is trichloro derivative. Let me just write that again. Derivative of sucrose. And is also sweeter than even what? Saccharin. It is sweeter than the saccharin, and it is approximately 600 times sweeter than sucrose. So that is the quality of sucralose is. And also, what is the quality of sucralose? One more quality that we have, again, it does not have any kind of calorific value. So it has no calorific value. So it will not result, it will not be harmful for the diabetic patients. So diabetic patients can consume it. Also what? It will not result into the tooth decay as well. So no tooth decay. And also it is serving as a sweetening agent. So much sweet. So it is all in all serving our purpose. It is not affecting at all. Now what is actually in this case, this very case of sucralose? So as I told you, it's a trichloro derivative of sucrose. We'll just be discussing the structure of that. Also, what is there in sucralose is, you need to find out about that, and let's go on to the structure. So just try to recall, or just try to have a slight concept about it, a slight development of a concept. Try to correlate with the other sugars that we have done, then I'll be taking up that point. So here is the structure for sucralose first of all. Let me give you a hint. The last point that we are going to discuss for the sucralose is actually associated with the temperature changes. So what was serving as a drawback for temperature changes? Which artificial sweetener was having this kind of a drawback? Yes, that was what? That was aspartame. So aspartame was not able to sustain at higher temperatures, so it was not fit for cooking or baking purposes. But yes, here that is the advantage in sucralose, that it is fit for higher temperatures. So it is fit for higher temperatures. That means it will not decay. It will not fit for cooking as well as baking. So it is fit for cooking as well as baking. So I hope you all have written this down. All these points will be included under the category of sucralose. Now let's just move on to the structure. So what is very similar to the structure? The structure here is similar to sucrose. Why? Because as I told you, it's a trichloro derivative of sucrose. So what is sucrose? Sucrose is a combination of two kinds of sugars. What two kinds of sugars? One is the alpha D glucose, the second is the beta D fructose. So I have got sucrose as, so once we get the structure for sucrose, we are actually making the structure for sucralose in a jiffy. So sucrose is basically a combination of alpha D glucose plus beta D fructose So that is what we need to make first of all. So first of all, in order to draw the structure for sucralose, draw the structure for sucrose. So that is what we are going to do over here. So let's draw alpha D glucose first. A 6-membered ring, and what I need to have here, we need to have a glycosidic linkage as we have done it before. Now what? A 5-membered ring, so it would be something like that. So that is how the 5-membered ring would be. CH2OH, OHH, OHH. So that is what? Nothing but beta D fructose, and the remaining one is CH2OH, H. What else? I need to complete all the groups over here as well. So I have got OHH, 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 and yes, I need to make this very OH upwards. So let me just correct that off. OH, H. I hope that is clearly visible to you. Now OHH, and finally CH2OH, H. So that is nothing but the sucrose, the structure for sucrose. That is sucrose, and that is glycosidic linkage. So I hope you all are following up. It's very easy. Now we need to form a trichloro derivative. Structure for sucralose. Here I will be writing as trichloro derivative. So that is what we need to make. That means I need to attach 3 chlorines over here. Where are the 3 chlorines attached? Now let's move on to the attachment. I need to attach it first here, then over here, and onto the 4th carbon. If I number this as 1, 2, 3 and 4, and this as 5. Here let me just number it again. I have got carbon number 1, 2, 3, 4, 5 and 6. Here I have got 6. Even here I have got 6. So where do I need to make the changes? First of all, onto the first carbon, carbon 1. I need to make here at the carbon 6. Here I am talking about the fructose. Replace the OH with Cl, and here at carbon number 4. At carbon number 4 I need to make the changes. That means for the glucose I am talking about. So let us just make the changes and make it sucralose, convert it into sucralose. So I just need to remove the OH groups over here. So I hope everybody is following me. I have removed the OH here. And let us just now have the structure. So the structure would be Cl, Cl and Cl. So that is what sucralose is. I hope you all have got the idea how to make the structure for sucralose. So let me just replace the name with sucralose. So that is nothing but sucralose. So I hope you all have got the idea how to make the structure. It's very simple. You just need to have a trichloro derivative as the name suggests. So I hope you all have followed up and you all have understood it very well. Now let's move on to the very last artificial sweetener that I would like to discuss, and it has got so much of sweetness that it is uncontrollable. So what is that? It is Aldehydes. The last one that we are going to discuss is Aldehydes. Can you imagine how sweet is this? It is approximately 2000 times sweeter than the sucrose. Yes, you heard that right. It's 2000 times sweeter than the sucrose. So basically whenever it gets into the food, what happens? The sweetness is not at all controllable. Its sweetness is not controlled. When it is added, or I can say not controlled but uncontrollable. That would be more appropriate. Uncontrollable when it is added in the food. So that is how sweet is Elitame is. And also what? It is again not having any calorific value, and again what? No calorific value. And what is the another thing over here? Again, it can sustain high temperatures. It can sustain high temperatures. So I hope that is very well clear to you. Now let's move on to the structure. How to make the structure for Elitame. So it's very, very important. The structure would be again combination of alpha amino acids. So it's again a combination. First I need to combine aspartic acid again, just as in the case of aspartame, aspartic acid plus what? I need to combine it with the alanine. So here I would like to have alanine plus another kind of attachment. So I would like to discuss that attachment as well. So first of all, you need to just have similar kind of connections what we have actually done in the case of aspartame. So let us just have the structure. Aspartic acid. So what is aspartic? Again having COOH, CH2. What else? I need to have CH, NH2, C double bond O, and the NH for that. This is nothing but the peptide linkage that we are going to form. So that is NH. NH I am taking for the alanine here in this case. And what else does it contain? Here it would be again C double bond O, again a peptide linkage, NH. And now what do I have here? I have got something like this. This connected with two methyls. So that is what the structure. This was the attachment that I was talking about. So here what do we have? We have got the aspartic acid. It's a dipeptide linkage. I have got two peptide linkages over here, and that is what is aspartic acid. That is what is alanine. And the aspartic. So I hope you all are able to follow up, and this is the extra one, this is the extra part that we have connected over here. So this makes a a brilliant sweetening agent having 2000 times more sweetener, 2000 times more sweetness than my natural sugar, that is the sucrose. So I hope you all have got this. We are through with the artificial sweeteners here. Let's move on to the type of preservatives. What are actually the preservatives are? So just first note this down, then I'll be taking up the next topic. So now let's move on to the another class of chemicals which are added within the food, that is nothing but the preservatives. Preservatives are very commonly used these days. Almost in each and every food which is available in the market is having the preservatives. Preservatives containing foods are actually unhealthy for us, so they need to be avoided. What actually the preservatives does? Why there is a need of adding the preservatives? So here is preservatives. So what are preservatives? Again, a kind of a chemical in the food. So that is a chemical in food naturally. So why there is a need of addition of preservatives? So what actually the preservatives does? Their function is the main answer here. So the function what it does is, how do it increases the shell life? It increases the life of a product. To be very precise, a food product. So how does it increases the life? Life, or we can say the shell life. So what happens whenever we try to store a food? Whenever we try to store some kind of a food, what happens is the microorganisms, in some time the microorganisms start growing onto that food. What happens is they start their metabolic processes, they start growing in colonies, and what happens is finally the food product gets degraded. That is what they does. So in order to prevent that kind of a metabolization of the, or I can say the growth of the microorganism, the growth of the bacteria, fungi onto what? Onto the food materials. In order to avoid that, we actually add some kind of chemicals in our food in order to, which actually prevents the growth of that bacteria, inhibits the growth of that bacteria. So basically that is what the purpose of adding preservatives is. So what does microorganisms? The role of microorganisms in food. First is this thing. That means what do? They first of all, they start growing in food. What kind of a food? The stored food. And hence degrade its natural properties. So they degrade its natural properties, making it unfit for eating, making it unfit for eating. That is why we store our food in refrigerators. What it happens is, the refrigerator provides an environment, that means the temperature is very, very low. It adjusts the temperature around 5 degrees Celsius. Within the refrigerator, the temperature is around 5 degrees Celsius, which is unfit for the growth of the bacteria, unfit for the growth of most of the microorganisms. What is a favorable temperature? It is approximately 30 to 35, or I can say up to 40. So that is a kind of a favorable atmosphere, favorable temperature in which there is microbial growth present. So we do not leave in summers, mostly in summers, we do not leave our food just like that into an open room or something. Why? Because again the microbes, the organisms start growing onto that, the bacteria start growing on, and it degrades our food, making it unfit for eating, unfit for consumption. So what we do is, we actually try to store it in refrigerator to actually avoid the growth of microorganisms. So that is what the role of microorganisms is. Now what does actually the preservative does? What are preservatives? Here is the definition now. So basically, those chemicals in food which inhibit the growth of bacteria, thereby increasing the food life, That means now the food can be consumed for a longer period of time. That means food can be consumed for a longer period of time. So basically that is what the role of preservatives is. Preservatives actually, it increases the life of the food. Now we can consume it. You must be having an idea about the manufacturing date that is written on the foods that are available from the market. So the manufacturing date is what? It is actually the life of that food, that particular food. The preservatives have been added onto that food and they increase the life. So it may be 1 year or 2 years. For some of the food materials, like if you have got a milk, if you have got 1 packet of milk, or if you have got 1 packet of the breads. So what is the actual manufacturing date and what is written over it? Best before how many days? So it is actually the life of those breads and the life of the milk is actually in days, because the number of preservatives added in is very less in order to make it consume freshly and in order to have its nutritional value intact. So less amount of preservatives it added in those. So I hope you all are getting it, how the preservatives are working and how you can observe the kind of preservatives. There are always mentioned at the back of the packets of each and every food that are the preservatives added in the material or not. If it is not added, it must be consumed as soon as it is opened. Because why? It will then attract the growth of microorganisms. So in order to avoid that, you need to consume it quickly. So that is how they work. Now let's move on to the type of preservatives. What we have? We have got 2 classes of preservatives over here, class 1 and the class 2. So here what we have got, the class of preservatives. I have got class 1. Class 1 are the simple preservatives. You must have observed your mother or your grandmother making pickles. So what do they add in the pickles? They add sugar, they add table salt, they add vegetable oil. So all these things are nothing but serving as the preservatives under the class 1 category. So I've got class 1 and class 2. So you have got the idea. Class 1 is table sugar, salt, vegetable oil. So here under the category of class 2, what all chemicals do we have? Here we have got what is this? This is sodium benzoate. That is the another class of preservatives, class number 2. This is easily metabolized within our body. This is a kind of a preservative that we use. And what else? Sorbic acid, propanoic acid, and their salts. So basically they are used in where? You need to find out about that. So these are the some of the preservatives that I have told you, and what they do is they inhibit the growth of bacteria. Again, inhibit the growth of microbes. So in what all things are these kind of preservatives used? You need to find out the answer for that. I'll be discussing the same in the next session, and I'll be starting off with the topic of soaps and detergents. That means we are only left with one topic, that is the cleansing agents. Till then, have a good day and take care.